Okay, so this is Chapter 2, Objective 5, Implicit Differentiation. So one of the things that we will be mostly paying attention to is what are we taking the derivative with respect to? Okay, so derivative with respect to. And we're going to use that with respect to kind of terminology quite a bit. So I will just always abbreviate that. So what does that mean? So derivative with respect to. So we will be looking at, is it d over dx? Is it d over dt? Or whatever the variable is. Maybe, d over dc or something, right? So that with respect to piece, that's this component right here. That is telling us the variable of choice that has a rate of 1. Okay, so a variable of choice with a rate of 1. So let's see what we're talking about. So let's say that I have an equation d over dt, so I'm taking the derivative with respect to t. And let's say I have the equation maybe a equals pi r squared, right? Even though pi r round. So we've got pi r squared. So if I take that derivative, so I am taking the derivative of a, so that would just be 1, right? Because that would be power rule, so that would be 1 a to the 0, so that would be 1. But I have to make the statement that I just took the derivative of a, and I took it with respect to t. So meaning that that rate is not going to be just 1 because it's not rise over run 1 over 1. It's whatever a changes compared to t. So I have to always write down its rate as well because it's the rate of a changed with the rate of t, right? So then now let's take the derivative of pi r squared. So for that, so pi is just a coefficient there. So 2, I'd bring down that 2, so that would be 2 pi. Reduce the power by 1, so that would be r to the first, right? But I took it with respect to t, so then I have to say times r's rate of change compared to t, so times dr dt. And that would be the derivative of a equals pi r squared with respect to t. However, if I were to take that derivative instead, so that same derivative, and I want to take that derivative with respect to r, so with respect to the radius in this case, right? So if I were to take this derivative, the same, so I'm going to just go through and do the same process. So this would be a to the first, right? So I bring down the 1, so 1 a to the 0, which would just be 1. And again, I'm looking at the rate of a and comparing how it changes with the rate of the radius. So the area's rate changed with, or in comparison to the change of the radius's rate, right? So that would be 1 times, I took the derivative of a with respect to r. And then over here, so same thing, so 2 pi r, so that doesn't change, so 2 pi r. And then now if I say, okay, well, how did the radius change compared to how the radius changed? Well, that's just going to be 1, right? 1-to-1 ratio. So I took the derivative of r with respect to r, so this would just be 1. And so I wouldn't need to write that piece, right? So I would just have dA over dr is equal to 2 pi r. Okay, so that is like our with respect to component. So let's go ahead and take a look at an implicit differentiation problem then, so which will have to do with these rates. So let's say that I have, so we want to find dy over dx, and we have this problem here, so x squared y plus 2y is equal to 4x. And I want to find dy dx. So that means, so because that's a dx here, I want to take that derivative and I want to do it with respect to x because of that right there. And then on this one here, I am going to have to do product rule, right? Because I have a product of two variables, so this will be my equation 1 and 2. So I have to do product rule there. So let's go ahead and take that derivative, keeping in mind we're doing it with respect to x. So this would be 1d2 plus 2d1. So 1, and then d2, so the derivative of y. So we would bring down that 1, and then reduce the power by 1, so 1y to the 0. And then times its rate of change, so dy over dx. So equation 1 copied, and then d2, so bring down the 1, reduce the power. I took the derivative of y with respect to x, so 1 d2, and now plus 2, so 2, just copy it, and then d1. So the derivative of x squared, so bring down that power of 2, and reduce the power by 1, so 2x to the first, and now times its rate of change. So I took the derivative of x with respect to x. So that was an x variable I took the derivative of with respect to x. So all of this, though, is 1d2 plus 2d1 product rule. And then now plus, take the derivative of 2y, so let me make that a power of 1. So that would be 2 times 1, so 2. Reduce the power by 1, so then instead of y to the first, that would be y to the 0. And then I just took the derivative of a y variable with respect to x. So what do I need to multiply that by? The derivative of a y variable with respect to x. And then let's do this right here. So the derivative of 4x, so that would be 4 times 1, so 4. And then subtract 1 off the power, so that would be x to the 0. And I just took the derivative of an x variable with respect to x. So I just took the derivative of an x variable with respect to x. And then once I get here, I just need to do a little bit of simplifying. So let's go ahead and do that part. So I have y to the 0, which is just 1. So this would be x squared, and then dy over dx. And then plus, let's get this in the right order, so that would be 2xy. And then that's just equal to 1, so I don't need to write that down. And then plus, and then y to the 0 is 1, so that would be 2. And then dy over dx. And then this would be equal to x to the 0 is 1, dx over dx is 1, so that would just be equal to 4. So then now we have to find dy dx, so we're going to just solve for it. So solving for it, so I'm going to move any non-dy dx terms, leave that there, and then this does not have a dy dx, so I'm going to subtract it over. So I want to subtract 2xy over, and that's because I want this side to have dy dx in it, and then this side of the equals no dy dx. Okay, so the left side have dy dx terms, this side no dy dx. So then I have x squared dy dx, and then that will turn to 0, plus 2 dy dx, and then equals 4 minus 2xy. And then now I'm going to factor out that dy over dx. So I'll be left with x squared plus 2. And then lastly, to get dy dx by itself, I'm going to divide this over to the other side. So 4 minus 2xy will be my numerator, and x squared plus 2 will be my denominator. And that's it.